In the first part of this course, Professor Ronninger began describing the journey of the data revolution in medicine from the perspective of genomic data. A person's genome is very significant to disease and health. But as Maya has just asked, what about the things that happen after the genome was defined, at that sporadic event a long time ago during that night with the wine and chocolate? What about all that our body has been going through over its lifetime? Things like how it interacts with the environment, its nutrition, the drug it receives, infections, immunization, injuries, surgeries, and also things like demographics, our work, our lifestyle, and so on. They all affect our health as well. Well, in the scientific discipline of biomedical informatics, analyzing genomic data is not where the story ends. It's only where it begins. Surely, the data revolution in medicine cannot be complete without considering both the genomic and non-genomic aspects. Luckily, in addition to the advancements in data science in recent years, a parallel revolution is going on, which by many aspects is independent of the data science revolution. This is the digitization processes of medical records from various kinds and sources, which are usually referred to as EMR, electronic medical records. It is a big IT revolution happening in hospital, clinics, pharmacies, etc. But also, it is amplified by many consumer products that assist and encourage people to self-report health-related information through smartphone apps, wearable, social networks, and so on, as was shown in the paper that Maya discussed earlier. This kind of medical data jungle comprises numbers and texts and images from different sources over a long period of time with inherent problems such as noise, different levels of uncertainty, sparseness, missing values, differences in units, in formats. It makes the very standardized state of genomic data look like heaven. And this is one of the reasons classic statistical tools are not enough and sometimes are not capable of analyzing such data. To our help comes a very powerful technology called machine learning. It is also the basis of artificial intelligence. Machine learning is the ability of computers to analyze data and learn insights out of it. So how is it different from statistics? Well, statistics is absolutely the basis of any machine learning. But machine learning adds to this basis two main capabilities. First of all, it is just the use of today's strong computational capabilities to automate statistical analysis. The automatization is not just for replacing manual work. It's what enables scale. Running tons of analysis from different kinds, concatenating output of one analysis as the input of another analysis, making such computation pipelines. Many times autonomously, while making many trial and error processes until meaningful correlations are found. That's an extremely powerful approach to look at the EMR jungle and make sense out of the mess. The second benefit of machine learning on top of statistics is the ability to not only analyze the data we have, but also to find the missing pieces in the inference puzzle, to create something new. This could be to raise an hypothesis and connect the dots, the raw data that we measured, in light of this hypothesis. Then, of course, see if it makes more or less sense than many other potential hypotheses. This could be to play with the data in order to question a certain analysis, for example, by finding an alternative and sometimes contradicting explanations to it while assuming a certain fact. This could also be learning how human experts analyze the data, interpret data according to whatever medical considerations they have, and replicating this process on a new data. The last point is also how we categorize different machine learning techniques. This categorization is mainly between unsupervised machine learning and supervised machine learning. The meaning of supervision in this respect is guiding the analysis process with data of examples, such as made by human experts. We will begin with the simpler approach, or simpler kinds of data, which is using unsupervised machine learning to learn from raw data without the examples of how to do it. Later, we will switch to supervised machine learning. So, I hope you enjoy learning machine learning.